Good afternoon, summer school participants. Good afternoon, people on YouTube and Facebook. I'm very happy to introduce Claire Lemercier, a research professor based in Paris, France, where she is affiliated with the National Center for Scientific Research. Claire's field of research is modern history of France, particularly the French economic institutions, justice, work and commerce. And coming closer to today's topic, numbers and networks, Claire is a specialist in quantitative history and network analysis. I got to know about Claire's work and methodological insights through the historical network research community, which is an active group of historians that share the interest in using network approach in their studies. And by the way, this academic community has a web page named historicalnetworkresearch.org, which is full of resources and event announcements. So check it out in case you were not yet familiar with them. But now I'm happy to give the virtual floor to Claire. Thank you, Claire, for being a part of our summer school program. The floor is yours.
Thank you very much, Ida, and I hope you can all hear me properly. I apologize for the short lunch, apparently, after the probably very interesting, important, but also tiresome workshop. I will also talk about networks today, but this will be the second part of this talk. And first I will try to situate myself, probably yourselves, and other people in this strange continuum or divide between quantitative history and digital humanities. But first, let me, of course, apologize for not being with you in person. I could not organize this. But I would very much like to thank already the organizers who made me feel very welcome, however remotely, and who shared with me the materials and also the link to the reflection sessions. And I was so happy to discover this format. I will certainly implement it if I organize something similar. And actually, it reminds me a lot of what Claire Zalk, my colleague in All Things Quantitative, and I have been doing in Paris for years, which is basically to share problems and solutions together. So I wanted to make two promises to you. The first one will be easy to hold, is just to send the presentation afterwards so that you can have it, which might be useful because it includes links to many references of handbooks, but also case studies that I like. So do not bother writing down the names of the authors. You will get all this. And the second promise is more hypothetical, but if you like, it will also be remotely, but at some point we could have a small workshop if 2, 3, 4, 5 of you would like, after my talk, feel interested in my feedback on your research, because that's what I like to do basically, is not to lecture, even though I try to do it today, but it's rather look behind your shoulder at your sources, your data sets, your questions, try to give advice and also learn a lot in the process. So it's basically what I will try to give you today is feedback from too many years probably of doing quantitative research, teaching it, hearing what other people are up to. Just to situate things, I did my first network analysis in 1998. So this is becoming really vintage, but hopefully it gives me some sort of perspective. And my talk will be based on will address actually two fields. First, the wide field of quantitative history and digital humanities generally. And what I will say in this respect will draw very much on things we have talked and written together with my colleague Claire Zalk. We have written a handbook first in introduction to quantitative methods in the humanities, and we have written a paper afterwards stating that our focus in all these things is actually on sources as historians. And this I will first present, this general stand on quantitative and the digital and history and sources. And then, more personally, I've been involved in doing network analysis, but actually more than doing it, teaching it and discussing it for a long time too. And so I will give pieces of advice or commentary, elaborating on things I have published already. But this is still work in progress for me because I work on examples from the research of people like you, including beginners. So there will be three parts actually in the presentation. First, I will try to present this idea that there are two separate lineages in what's called diversely quantitative, digital, formal approaches to history. And this is something actually it took me some time to understand. I drew this kind of diagram for the first time less than 10 years ago. And it arose from the fact that I was beginning to meet the two pros on the two sides of the divide, and I could not understand all the misunderstandings. So hopefully this sketch will help you situate yourselves and people you might meet in the future in these two lineages. And then I will try to explain where Claire and I stand in this divide and what we try to offer. We try to offer is first a way for the two traditions or lineages to meet, somewhere in between. And we also try to offer an alternative in some ways that we feel is more historical to some standard ways of doing things. And then, if you like, we can have a first shot. And what will be hopefully the second half, even if it's the third part of the talk, will be about networks. The image of my cat is based on previous H&R actually meeting where everybody was complaining about hair loss. That means some people call them spaghetti monsters also, which means network graphs that cannot be used actually because you don't see anything. So starting with this question on hairballs and is it really useful to spend a lot of time to learn producing a graph that I cannot read? So we will both try to solve this practical problem and address on the way the different traditions that also exist in network analysis, and especially network analysis in history. So let me start with the two lineages. And I know the idea is super abstract to start with, but let's begin with two things. First, I think the two lineages became really clear to me when Claire and I were writing our introductory book, and we were looking at the competition, of course, so we were looking at good ideas as to how to explain this sort of method that we could borrow to other authors of introductory textbooks, of course, citing them. And so basically we were looking at other introductory textbooks on quantitative, digital, or formal methods intended for historians or for neighboring disciplines, such as literary historians and so on. And I put on the slide two covers of two books that I really like. I think each of them is really good in its genre. But what was super striking when we focused on these two was how they did not overlap in so many ways. They did not tell the same story because each textbook tells a story of how quantitative history or digital humanities began. It's part of the thing and of writing this type of books, and we did it also. But they actually trace two very different lineages. They do not claim the same ancestors. They do not cite the same seminal works. The references do not overlap. The first thing that does not overlap is the references and the history. the emerging history of who came before us and what we can refer to. And the other thing that did not overlap, and this was very striking for me, was just a set of methods that you thought you should present to absolute beginners, because those two books are really good in that. I think they succeed in talking to absolute beginners, to people who have never quantified or used a computer to produce and analyze or visualize data. But the set of the basics, in the case of the book on your right, Exploring Big Historical Data, is very similar actually to what you have in this week in Riga. You have network analysis, you have maps, and you have language models, not AI at the time, but a bit like that. Whereas on the left, there is no mention, even as a more advanced method that would exist somewhere, of network analysis, for example. But conversely, on the left, in History by Number, a book written by two economic historians, what's considered basic is percentages, is tables, is a graph showing how quantity moved across time, perhaps. And then they move on to more sophisticated things borrowed from economists, such as correlation and regression. And so these books live into different universes, not just of references that you cite, but also of methods that you deem important for beginners to learn. And the other thing that actually led me to, at some point, create this visual with colors and so on, was the fact that, in fact, I was mostly taught myself on the left side, if you like, by economic historians and demographic historians in France. There was not much of a tradition of quantitative history when I was a student in the 1990s. It was out of fashion, but still, you could say I learned on the left side of the divide. And at some point, I discovered network analysis for other reasons. And because I used network analysis, at some point I was invited in digital humanities conferences. And we taught totally different languages. We could barely understand one another. So it was, I was really lost in translation or without translation. But then I endeavored to try to put parts of the two words together and at least to provide this map and partial translations, so that if you find yourself in the same situation that I was in, if you began in Riga on the blue right side, and you find yourself in your department with colleagues who think digital history is rather like the thing on the left, at least you can understand the misunderstanding. So just to flesh out a little bit, to develop what's on each side of the divide, because you have different words, and to talk about the thing, you will have more some things alluding to quantitative or numbers on the left, and you even have the word plyometrics, like measuring stuff in history, used at some point in time. Whereas on the right, the emphasis is rather on the computer as a tool or the digital as a format, because it's related to the fact that outputs on the right are less often put in the form of actual numbers, or tables with numbers. Numbers, of course, are behind this all, and digital is about numbers, but on the right, in the digital humanities tradition, you have more emphasis on visualization, and also sometimes different visualizations. Of course, you find figures and even maps on the left, but they also like their numbers, like just large tables of numbers, whereas on the right, the emphasis will often be on producing legible visualizations or even beautiful visualizations. And this could be related to who created each of these traditions. They were, of course, born of encounters between historians or other humanists, let's say specialists of the arts, be it music, literature, paintings, folklore, or whatever. So historians or humanists were one part of the encounter on each side, but the left side, or red side, was one of repeated encounters between historians on the one hand and other social scientists or people in the social sciences. Depending on countries, periods, specialties in history, those could be sociologists, economists, psychologists, geographers, and so on. And so in each case, you had slightly different techniques being borrowed, but the general spirit was you had in the social sciences older traditions of quantification, themselves, of course, born of encounters with statisticians, mathematicians, and so on. And historians borrowed some ways of constructing data sets, of building data, and of analyzing data from discussions or readings of the works of sociologists, geographers, economists, and the like. Whereas on the right, what's called digital humanities was rather born from historians also, but identifying rather as humanists than as social scientists. As you know, I guess history is somewhere in between or in the two sets at the same time, depending on the countries. Could be rather seen as part of the humanities or part of the social sciences. Digital humanities were rather born, as far as I know, from literary studies, meeting with computer scientists, so no social sciences involved. And another important element is that heritage professionals, I mean librarians, people working at museums and so on, were also very much involved in this birth of digital humanities. The two things are rather old, actually. The phrase digital humanities flourished in the 21st century, but they trace their ancestry much earlier on with the founding, for example, of the Journal of Literary and Linguistic Computing. So at the time, in like the 60s, 70s, the keyword was computer rather than digital. And so you didn't have digital humanities, the DH phrase per se, but you had something very similar that is claimed as ancestry of digital humanities today. And the more or less, the origin story, let's say, is that of a guy working on the Bible, meeting people at IBM, the computer firm, and starting indexing the Bible in a more automated way. So this is important as an origin story because it points to digital humanities being at the beginning about corpora, so large sets, first of text, because it began rather with literary studies, and then it could become large sets of stuff you find in museums. It could be paintings, could be all of those sorts of artifacts, could be music in the form of sheet music. So large sets of works, corpora, and what you wanted to do was, I think, enhancing scholarly editions. So the first thing was making more automated indices, indexing. That's why named entity recognition is still so important in the field. The first idea was, is there a way to automatically recognize, for example, all places in this large set of corpora and create an index of places? That's basically more or less how it started. On the left, it started also quite early on. The institutionalization, the creation of journals, is also happened in the 1950s, 60s, 70s. And you can always find ancestors earlier on in the 20th century. And it started with the motto in history of new economic history, new social history, new political history, especially in the US, but you had variants of this in other countries. And one of the phrases that stayed was social science history, to put all this together so people could work on economic, social, political, or even cultural history, but if they borrowed quantitative methods from the social science, that would be social science history. And today you have a journal under the name Social Science History that still exists and is thriving, and you have conferences of the Social Science History Association, meaning basically that you find historians who are not allergic to numbers in there. And so what they all began with was this idea to study not just the elites, but the masses, to study large-scale phenomena, and that for this you needed numbers. And they wanted to create tables with percentages and correlations, as was done in other social sciences, so as to say something a bit general on large phenomena, to give some measurements. I haven't put the word measure or measurement on the left, but it could be there. So you see at the beginning quite different encounters, quite different topics, and quite different methods. And moving forward to, and just one thing I wanted to say, excuse me, is from the beginning actually there was something a bit in the middle, if you like, is what is called today distant reading in literary studies. So the phrase distant reading was very much used by Franco Moretti, but the thing existed long before, and it's an interesting exception as far as I know. The general idea of counting words to characterize texts and to create sets of texts that have different words inside and so on, it was used in literary studies, but it came, as far as I understand, rather from sociology than from the classical traditions of digital humanities. So you had things in between. The two traditions were not completely close to one another, they have never been, but mostly they have evolved separately. And so if we look at today where we are with all this, you end up with very different one-week summer schools for newbies. For example, it's interesting that you had, or you were having an initiation to Python as a language, whereas if you were in the context of social science history, you would probably get an introduction to R as a language, which is not much of a problem because the two languages are based on very similar principles, and once you learn a bit of Python and you become comfortable, it becomes extremely easy to switch to R if you have to at some point to collaborate with people, for example, and vice versa. But it's interesting in a way that those are just languages, there is no proprietary software or whatever. You still have a divergence of use with rather Python on the side of digital humanities and R on the side of quantitative history. You also still have differences in vocabulary to talk about the same things. For example, you will tend to use the word metadata, data and metadata, in the context of digital humanities because it's more or less obvious in digital humanities that your data is works of art, text, painting, and so on, and metadata is the date, the author, the location, whatever, what's external to the work of art. And metadata is also a vocabulary used in library sciences, of course. Whereas in quantitative history, you will talk about basically the same things, like columns in your dataset, as variables, which is the jargon used in the social sciences. The variables are the characteristics of the individuals we are interested in, because we tend to think of the individuals who are interested in as human beings. You will often get as an example of a variable, gender, place of birth, occupation, things like that. Whereas you will get as examples of metadata, author, place and time also, because you think, first of all, of your individual of interest as being a human being on the left and a work of art on the right. But in fact, the methods you are taught in each context can apply either way. You can use the methods on the right side to study works of art. You can use the methods on the right side to study human beings, and many people have been doing this. It's just that the basic set of examples you are given when you begin and the references differ. As far as software is concerned, you also, I think this divide is becoming less strong, but you still have this idea that before going to R, you will start with a spreadsheet editor, such as Excel or Calc, on the quantitative side, whereas in digital humanities, you will directly need a relational database, which is something, of course, very much influenced by the tradition of cataloging that's present here. And for a catalog, you do need a relational database for a PhD dissertation. I think it's debatable. And as I mentioned before, there's a strong tradition of focus on visualization on the digital humanities side. I think for two reasons at least. First, because the humanities have a less easy relationship to causal question. I think humanists like to say they describe and they do not explain stuff, or they interpret but they do not explain stuff. Whereas economists and many sociologists will not hesitate to say they look for explanation, they look for causation. And visualization, of course, is good for description and could be good for causality also, but it's a different matter. And the other reason maybe why visualization is important in digital humanities is the engagement with heritage professionals who want to provide visualizations not just for researchers, but also for a wider audience using their websites, or even to produce visualizations for use in exhibitions. So this whole landscape, of course, changed with the advent of the phrase big data and then with the advent of AI. And what I just want to say, this happens on the two sides of the divide, more or less evenly. And what I want to do today is basically to say, to introduce you to this divide so that you can navigate it. If you meet people from the other side, identify the misunderstanding, but also incite you to maybe bridge it, because I have given a bit of a caricature, and many people actually do not know yet that the other side even exists. It's not that they hate each other, actually, it's that they ignore each other. But many people have bridged this divide, and I just wanted to give you a few ideas as to what you can do in between, or what you can do just beyond in other places. And here I will go more quickly through the slides, not that I don't like them, but because they are more intended as things you can refer to later if you like, or we can go back to in the discussion if something seems interesting. So, assuming that you are on the blue right side of the divide, most of you, you have been placed there this week, or you were already. Why not check the other side? First, by just using numbers sometimes, just creating simple two-way tables to check correlations between variables. And I put an example of a paper I like so much also for other reasons. And it's related to social ties because it's about people who visit one another's household and tell about it in their diaries in the late 18th, early 19th century. But just to say, sometimes a table is also a good tool to make your point. Also, about social ties, you don't necessarily need a graph to show that, for example, female diarists had different patterns of visits from male diarists. I also included examples of regression, this thing of economists that's often thought of as rigid, firmly on the political right, too causal for humanists and so on, but you have uses of regression that can be interesting for digital humanists. So I put two examples, one of them including questions on ties and networks. And then I wanted to mention the in-between in terms of methods that are quite descriptive, suited to small numbers of observations, so definitely not big data, and different to place in the divide, in that they are rarely used on either side, but I think, and Claire and I found out in our research that they were often useful for historians. So I just gave it two examples on slides. One is sequence, and those are methods we discussed at length in our introductory textbook. One is sequence analysis, that's about describing trajectories, so people who change state over time, be it geographical trajectories, professional trajectories, gender trajectories, literary trajectories, or whatever. And the other one is factor analysis. That's a method that's useful when you have many variables or many metadata describing the same individuals, and you want to create typologies. You want to see how all these variables, like 20, 30 variables, 20, 30 characteristics of the same individuals or text or works of art, how they are arranged together. And you want to end up with 2, 3, 5 types of individual text and so on, based on all your information. Then that's the technique for you to use. And so this moves me, of course, to what Kazak and I have been trying to promote, and I will be shorter here also because it's shameless self-promotion in a way, but I wanted to just give you a taste of what we do in our book and what we like in the examples we cite, including the examples I will cite in the rest of the presentation. So I try with the being mean with the two other traditions as what you want to do when you are in each tradition, what you want to produce, where you want to publish, and the risks. The risk, for example, on the digital humanities side is that your end product is a fancy website that will be short-lived. But I think what I want to focus here is what we don't like in both cases and what we've seen worsen in recent years is a trend toward larger and larger projects with a lot of money, a lot of people involved, a lot of discipline, involving more and more standard tools and more so-called data cleaning, or so-called disambiguation in the age, that the idea that your data should be as standard as possible to be used on a very large project, so that every library is compatible with every other library and so on. And the aim of this large project, to go really far in the caricature, is to publish in interdisciplinary or even life science journals such as Nature. And just to give you two examples of why I hate this trend. This one is old, it was published in 2008 and I've been using it ever since, is Nature trying to pimp up really historical research on notarized contracts in medieval France, saying social networking gets medieval. Researchers give a French province the Facebook treatment. And the selling point is the fact that, wow, people already had social relationships in the medieval period. Can you believe it? So of course it's absurd, and the underlying research is not much better, because what the colleagues did is input thousands of notarized contracts, and in the beginning they wanted to consider all social ties inside the contract. It could be very diverse. You married someone, you lent money to someone, you were a witness for someone, and so on and so forth. But the historians doing this were to computer scientists who said, we want big data, we don't want complicated data. And so they ended up with the definition of social tie being, I am in the same notarial contract as another person. And from this definition of social type, the big result was that social types were clustered by place. But people in the same village tended to be in the same contracts together. So not much of a result at all, and a sad case of interdisciplinary research. And this keeps coming up. A recent case of whatever can be published is very bad analysis of paintings that was commented on by a Polish historian of art called Mateusz Lafiński, who created this quote I like so much: historical data is not your familiar kitten. And he said, or he hoped, that historical data is a saber-toothed tiger that will eat you and a village of data scientists for breakfast if you don't treat it with respect. Well, it's aspirational, because in the end, I think it's always the data scientists who win the money and the publication, and the historical data that lose it. But it exemplifies what Claire and I have been trying to do for years, is put forward historical data and treat it with respect. And so what we want to do to this aim is mix tools, that's the rainbow part. So local is to learn tools from the two sides of the divide, the quantitative history and the digital humanities side. And choose a tool not just because you were taught it, because you were taught in the tradition, for example, of digital humanities, but choose a tool because it fits your question sources and resources. And this implies discovering a large number of tools, even if you don't have a deep knowledge of each tool, of course. I myself am not a specialist of every possible tool, but I try to know of their existence in case at some point they become useful for my research. And this involves experimenting, basically, trying stuff just for fun. Something that historian Daniel Milo called gay science. I think the play on words was intended. It's also non-straight, non-standard science some time ago, so try stuff. And the other things we try to promote is to keep things relatively small scale. We don't hate large projects. Actually, Claire is finishing a very large ERC project right now. But we try to teach stuff that you can do on your own with your computer doing PhD research. So start with simple tools and not make it a religion. As Eva mentioned, I'm not always a quantitative historian, and a lot of what I do is not quantitative. And the other thing we emphasize and have been emphasizing more and more in recent years is that we are firmly rooted in historical sources. And in fact, in our view, creating data sets is a way to immerse ourselves in our sources. Because if you create your data set yourself, it means a very close reading of the sources, actually, when you decide what in the source is the first name, the date of birth, the occupation of an individual, what is the date, the author, etc. of the work of art. You make a million small decisions, and you have to focus very intensely on the materials. So that's something we could call deep reading. I discovered this phrasing in one of Sanita's papers recently. But the phase of immersing yourself in data is super important. And so actually, we promote a version of quantitative history or digital humanities, but where source criticism is key. It happens at all phases of research. To oppose a version where you do quantitative history en masse with standardized tools and you don't bother with the details, such as source criticism. And this goes hand in hand with a hatred of the phrase cleaning data. Because we think the phrase is revelatory in a way. Cleaning is this thing subaltern women do, and we don't want to see them doing it. Data cleaning is actually quite often delegated to students, to underpaid research assistants. And what goes under data cleaning is actually the most important scientific decisions is what do I categorize as what? How do I categorize occupations, for example? Or how do I decide on a date if I have 2 or 3 different dates in the sources? So we try to put forward this question of weird, non-clean, missing, contradictory data exceptions as part of quantitative research. And I've been super long already, so I will not give you the little examples I was going to give here on this, and so that I keep at least 20 minutes for networks. But if you want to react or you want some clarifications or whatever at this stage, it's very much welcome.
Do we have some immediate questions or reactions? Seems that no, everybody's happy. Ah, was there? No. Okay, so I think we can go on.
I'm just tired of going with or practicing digestion.
I think everybody feels orientated in the field, so I think it's very valuable. Yeah.
Thank you. So, turning to networks for the remaining part of the presentation, I will shortly go back to the divide because it's a bit different in the field of networks, and then move on to more directly useful, maybe advice on historical network research. Going back to the 2 lineages, the story is a bit different in terms of networks. The chronology is a bit different, but you find a similar thing in that the blue on the right is the path that most digital humanists know and use, and the red on the left is the path that some quantitative historians, quantitative social scientists know and use. And so here too, the thing was reinvented independently in 2 different time periods by colleagues in different disciplines. On the left, sociologists, on the right, physicists and computer scientists. You have different handbooks. I just gave the name of the main authors. You have different software. Gephi, for example, is unheard of by sociologists, is solely used by digital humanists. You have, at the beginning, different research interests. And one annoying part of this story is that some terms of vocabulary to describe, for example, ways to be central in a network were reinvented over time, or more accurately, you have the same measurement of centrality in a network reinvented because the second guy did not know of the first guy and called something different. So this makes vocabulary a bit complicated, and I put a pointer in the presentation on one of the websites that clarifies this. So the sociological part, that's called social network analysis. You have a journal, Social Network, you have an International Society of Social Network Analysis. You can trace it back to social psychologists, and the important thing is it started with really a piece of paper and pencil. They did not have computers at all at the time, and they started with smallish networks, 1,000 to 2,000 persons, but they were super specific as to the content of ties, the orientation of ties, which is our relationships reciprocal or not, and the local structures of ties. And here you have a diagram of friendships between school children, and classically you observe few friendships between girls and boys, and they discuss at length which friendships were reciprocated or not, and who were stars, both in the metaphorical sense and also in the graphical sense, because you appear as a star, like the girl, I think, on the right, if you have many people pointing at you as their friends. So microstructures, as they say, local structures, local shapes of small but dense and complicated networks. Whereas the physicists' interest at the beginning and the computer scientists' interest in the late 90s was actually the structure of the World Wide Web, one of the parts of the internet. So extremely large networks with millions, if not billions of nodes at some point, but they were not super interested in the tiles themselves. The tile was the fact to be connected or not be connected, and there is no orientation. If you are just thinking of two servers exchanging information, the information goes both ways. So it's a view that started with super large, but in a way super simple networks, where if you visualize it, it gets hairbolish, it gets complicated in a way because it's super dense, but the structure is super simple, and actually the physicists never visualize it with Gephi or something like that. They just go on to calculate indicators, such as in the graph in the middle that shows that few nodes have a lot of links and many nodes have few links, and they are content values. And so here too my message will be we should not hesitate to take things from the two traditions, to mix them for our actual networks. And in this specific case, as sociologists began with relatively small but complicated networks, and my experience is that in history we tend to have small but complicated networks. Maybe try to go look at some stuff on the right or left side. But to be more practical, perhaps you experienced this already this morning, but a lot of network visualization at first stage gives you this. It gives you an actual hairball where you cannot see anything, and it's a bit disappointing if you have put a lot of energy in having the proper data format and so on just to get this. So what can you do in this case? I will say you could use visual semiology, and I'll come back to this, but borrow also tools from the sociological tradition, the social network analysis tradition, or more generally the social science history tradition. And for example, you can look at this, the paper it's extracted from is really difficult to read, but the examples in the paper are fascinating. So it's really an important paper in the sociology of networks in the 1970s. And one of the data sets was about a group of monks. So they were isolated together over several months. And a researcher asked them repeatedly about their relationships with one another. So there were only 17 monks, I think, or 18, the number of rows in the table, but they were asked repeatedly as to their relationships with all the other 17. And not some vague term like, do you like them? There was like them, but there was also, do you have esteem? Do you have antagonism? Do you have disesteem? And there were many other tables. And you could put also an intensity. Do you like them on a scale of 1 to 3, and so on. So you see very small but very complicated data. And it's interesting that one of the outputs was create actually these matrices with kind of heat maps or these tables rather than graphs to visualize the information. So anyway, going back to our contemporary hairballs, that's an example we put in our handbook with Claire Zalk. Is I began with the hairballs on the left. Immediately already a bit readable because I put colors, or I put black versus white in it. And you see with the black versus white that you have maybe two hairballs, right? One between white nodes and one between black nodes. Without the colors, it will be even less interesting. So this is a visualization of relationships between places in the north of France in the 19th century. And the link is the fact that you had more migrations than expected according to the size of the places between these places. So let's say for short, the link is migration. And so I have a hairball of migration. This is among like 75 places in the north of France. It seems quite dense. So we could say there's a lot of migration in this region generally, and most places seem related together, but perhaps the whites are related together and the blacks are related together, and there is less happening between the two. And the white and black here refer to the language spoken people spoke rather French and these people spoke French. So this could be one first interpretation. But then what I proceeded to do is to abstract the visuals, and that's the first practical piece of practical advice, is really you want to subtract things from your visualizations, and it goes also for maps and for everything, and that's one of the key messages of visual semiology, is just once you have a view of the whole and it's super complicated, you create small views of parts of the whole, or actually points of view on the whole, depending each time on the question. So for example, here in the second one, I just move the nodes to geographical coordinates, and I see what happens with distance. And here, for example, I only keep the reciprocal relationships. So here you have a node, you have a link between two nodes, only if there is more migration than expected in both directions. And in the case of migration, you can see that reciprocity is important, and it's not necessarily intuitive, right? We often think of migration going like from the global south to the global north and not vice versa. So the fact that migration is reciprocal or not is super interesting, and one way to make the graphic more readable is to focus on which ones are reciprocal and which ones are not. And I won't go to the other versions, but the general message is edit things out. And in other cases, you will want to hide the nodes that are less connected, but less intuitively, you might want also to hide the nodes that are most connected to see what else happens. And I don't comment on this at length, but you don't have also to use this thing that's called node-link visualization. There are other possible visualizations of networks, including the matrix or heat map. That was the one used with the most also. And matrices that are not included in Gephi, but you can use other software, what are they good at? They are good at uncovering non-reciprocity, and they are good at uncovering hierarchy, like the fact that you have a densely connected center and a less densely connected periphery. Here you could say we have a center on the top left, we have a semi-periphery on the bottom right, and we have more or less isolated cases here, or boundaries. And this points to the fact that network analysis doesn't have to be about everybody being friends with one another, or everything circulating in every possible direction. Actually, the only reason to do network analysis is if not everybody is connected with everybody. Because if all the possible links exist, you don't need a graph. You just say all the possible links exist and you move on. The structure in network analysis comes from types that do not exist. Those are the white squares in my matrix. And here what I see is actually a vast majority of white squares. Of the possible migration links, most of them do not exist. Whereas on the contrary, with my hairballs, I have the visual impression of density because of visual cluttering. So this version emphasizes borders where things do not circulate and hierarchies, and could be useful if you have questions on this. And this is just to sum up in which cases software like Gephi works well and in which cases it works less well. In some cases, the first visualization of your network looks like this. You have maybe hairballs, but they are separated from one another, and you have a few things here that we call bridges in network analysis connecting the hairballs. A classical case is interdisciplinary collaborations in publications. You have islands of authors in the same discipline, in the three groups here, and you have few interdisciplinary collaborations. That's what called community detection in network analysis. So if your network has clear communities, you are all well with the tools of the physicists, you are always all well with Gephi, and and you do not have much of a herbal problem. Whereas, if there do not seem to be separate communities, if you have just one herbal that is maybe denser at the center and less dense at the periphery, but you don't have subgroups, you don't have separate parts of the network. In this case, the standard tools that are implemented in GEFI do not work very well. It's very likely that in fact you have a core periphery structure, so something very dense in the middle and something less dense in the periphery. And in this case, to put it shortly, I put more practical advice on the slide. That's the case when the sociologists part of the tradition might become more useful. And that was just advertising for two papers in the Journal of the Historical Network Research Group, actually, by young researchers, papers that I liked for many reasons, but among others, because they experimented with tools from the two traditions and created their own visualizations to fit their data. And I just want to end on this question of dirty data and source criticism that I skipped before, but putting it in the context of network analysis to give you a flavor of what we advocate for, right, with the phrase dirty data and with the return to source criticism. The first thing is some cases of research, I put two on the slide, where you have relationships between named individuals, for example, letters being sent from persons to persons, and you have some of the letters that are anonymous, or that are sent, we don't know to who. Or the other example, that's the example by McShane for the letters. The other example by Jean-Paul Rère is accusation of heresy in medieval religion, where people say other people are heretics. And the question is, who are you accused with? People denounce a group of people together, and the colleague is interested in the links between people who are denounced, who are called heretics together. And his problem is the source quite often ends with cum pluribus alis, which means with many others. So you have a list of names, and they were heretics with many others. And so I think our reflex in such situations of anonymous persons or anonymous groups of persons is just drop them from the analysis altogether. And in these two cases, they experimented with keeping those in the analysis. But they cannot be a node exactly like any other. So they experimented with different ways of keeping them visible, thinking of them as one person or a group of persons. And it's difficult, and I'm not saying they had the perfect answer, but just to say it's good not to drop the complications altogether, but keep them also in the visualizations, in the numbers, and see what happens. And the final thing, it's on several slides, but it's just one idea, is to compare data across sources using visualization and quantitative analysis, and in this case, a visualization of networks. And I will just present one case, but I give several other examples because it's not often done, and I think it's a super interesting avenue of research. This has only been published in French, but I know there's an English version somewhere. If you like it, I can provide it. This is a study in medieval history of all sources mentioning a queen of France who was called Emma. And so the colleague tried to map all social ties around Emma mentioned in the surviving sources, meaning not just the ties between Emma and other people, like her husband, her father, people she was a witness for, but also all the ties between all the people who were related to Emma. So this is basically a network analysis of the French, if we might say French for that time, elite, aristocratic elite at the time. But what she did was not just put all the ties in one big complicated visualization. She did this, But then she abstracted and she subtracted information to address questions. And one of the most interesting findings, I think, was just look at information according to different sources or different sets of sources. And so on the left part of the slide, you see all the ties and only the ties that appear in the main narrative source. That's, I think, a monk who wrote about current events, and he mentioned Emma and other people. That's what's called a narrative source. Whereas on the right, you have all the ties and only the ties mentioned in deeds. That is, acts of practical importance related often to the sale of land, for example, to saying who's the lord of the land. And Emma is the big blue dot. And you can see that on the right, she is at the center of her own network, and she is between two subgroups that are actually her own family and the family of her husband, the King of France. So if you look at charters, for example, at deeds, at contracts, you see her performing a role that was a bit central in that she was the interface between two groups of noble families. Whereas if you look on the right at the account of current political events by a monk, she is almost peripheral in her own network, and she doesn't have this preaching role. So you can see in this example how formal analysis, in this case of visualization, but you can back it up with numbers, helps us also to understand what each source says and what it hides. And it's not that one is truer to reality than another, but it puts emphasis on the point of view of each of the sources. And it's something that's particularly advisable if you deal with network analysis from composite sources, or just from sources with a lot of missing data, which is the case, in fact, of all our sources. And comparing sources can lead you to this critique, as done by Søren Sindbeck here in another study on Vikings, who says basically, I have created this beautiful visualization, but this is just a visualization of what's been excavated and what's not been excavated, because he's dealing with mostly archaeological sources, and he's saying, okay, I'm happy with this network, but actually it doesn't say much about reality. It says a lot about the state of our knowledge. So that might be a bit disappointing. That's also a cautionary tale about networks, but I hope it can be refreshing, and we can be proud as historians, actually, if we harness the tools of other disciplines, be it the social sciences, physics or computer science, to do what's at the core of our business, actually, to perform source criticism, to say what we know and we cannot know. And on this note, I've been a bit long, but I thank you and welcome your questions and comments.
Thank you, Claire. Yeah, so now we have some 20 minutes for questions and answers, reflection. Yeah, we have one more mic. And we have the owl camera in the middle who will face if you will start to talk. So Claire will see you better. So yeah, do we already have some questions? Okay, while other questions are formulated, I had a very kind of general question thinking about the functions of visualizing networks. I like the last which you mentioned, that it's actually a good tool for source criticism when you really work with when you do the research. Maybe you can tell more about your kind of your practice as a historian in your workflow. When you typically use the visualization, is it more for communication, or you really explore your data, or you, yeah, maybe on this?
Thank you, it's a great question. I think it's both, but the communication purpose is tricky with network visualization. not just talking from personal experience, but many people, many colleagues told me that, is most audiences are not used to reading network diagrams. And this idea that top, bottom, right, left do not matter, you don't have a scale, and what matters is whether the nodes are connected or not, and the most central in the network might not be the most central in the page, is not intuitive. And having done this for more than 25 years, at the beginning we were thinking, oh, people will get used to this, and it doesn't seem to happen. Even though you see more and more network diagrams, people have not learned to read those. So I would not advise it for communication, except if you do really the work of trying to abstract many different points of view and decide which one you want to publish, or maybe even better, but it depends on the audience. Use at least 2 diagrams so that the people understand the point you want to make is about the difference between the 2 diagrams, and then they might understand something. But in my experience, if you give them one, they don't see anything, or they don't see what you want them to see. So for networks specifically, it might of course not be true of maps or of the visuals, but I don't think it's efficient for communication, whereas I think it's essential just to figure out what's in your data. At some point, I was so annoyed with the ubiquity of network graphs that I was saying, do not use graphs at all, only use numbers. And it never worked for me. I think you need a general idea of what you have to go on and produce maybe numbers or simpler graphs. And just to exemplify this, I'm trying to find the right slide. I think the general question of is it worth doing community detection in my data or not, or does it not make any sense? I do not know of any other way to decide other than have a first look at my data, and is it more like this, or is it more like that? And you can always find indicators for this, but mostly visual inspection will tell you, okay, I have one core periphery structure, or I have an island and hubs thing. So when you get used to this, actually first glance you see, is it this or is it that? And then you can decide where to go in terms of, for example, do I need a matrix, or is it worthless? Or which kind of simpler visualization I will create. But those, I think, are mostly for me. I put them in working papers, but I would not generally put them in published papers unless it's in a journal specializing in network analysis.
Thank you. Oh, there is a question.
Thank you for your interesting lecture. I wanted to ask one question which relates on quantitative methods and network analysis. I have read previously in literature that there is a debate between historians when to start to do network analysis. For example, one part of historians are debating that if you have network where participants are no more than 10 people, then it's not worth to make it a network analysis, but maybe you have another insights or maybe further readings where to look at.
Thank you, it's a great question, and I will add a reference in the presentation to a thing I think by Martin During, who tried to write a decision tree, should I do network analysis or not? For me, it's really not a question of the number of nodes or ties. Large networks are interesting, small networks are interesting, and even with 10 individuals, you could see things in a network analysis that you could never see otherwise. I would say there are 2 key things. One is you need reasonably complete information. And let me go back to a slide for this. This is really a problem with a lot of, in fact, published studies of past correspondences, is they draw a network of who wrote to whom based on the letters that were preserved. And of course, nothing's ever complete in historical data, but for example, this is a case of ancient history, and this is supposed to be a network of relations with other scholars of this period, etc. But it's just the numbers of letters that we find in the archive for this period. So we have no idea, actually, of which numbers of letters were exchanged between these people. And the fact of drawing this network is problematic because it makes it more real in a way. The fact that there are ties here and not there. So it's not because it's small that it's problematic for me. It's because we know it's not at all complete. It's not random, but it's totally arbitrary what survived. And so what we are visualizing is what was preserved, not which letters were sent. And the other thing to keep in mind, and let me use another presentation, is in many cases it's simply not useful to use network analysis, whatever the size. If everybody is related to everybody, what I was saying is like this, you don't need to draw it. You just say nobody's related to everybody. If nobody's related to nobody, of course you don't need to draw it. But a case that I see quite often in publications actually is people drawing stars. And this is the person whose correspondence is preserved, and this is the person who writes to them. We know that it will be a star anyway, and the only question is how many summits we have, and if they were men or women, authors or not authors, and so on. This is a list, actually. So we absolutely do not need network analysis to visualize a list. We just need a list and a table. And it becomes interesting where there is structure that is not trivial. So some parts are dense, some parts are not so dense. And this is a small network, this is a large network, but each of them deserves network analysis if we have a structure that's not easy to sum up in 2 words.
Yeah. Yeah, there is one more question.
So thank you very much. As you already mentioned, historical documents, they are often not complete and there is some things missing. And when we talk about visualizations, we often also hear how can we actually visualize uncertainty. And I think that also applies to network graphs. Do you have examples or ideas how we could visualize this uncertainty in network graphs?
Thank you, that's a super important question, and as I mentioned, we've become more and more interested in missing and weird data. So it's very much on our agenda, and the answer is really not easy. But I think the general direction is simulate and experiment things. And actually, some of the slides I skipped through at the end were about this, inspired by archaeologists, actually. Let me retrieve the slide. So I put references to papers by archaeologists in the talk, and they discussed testing for robustness. And one of the things I had not imagined before reading archaeologists is actually one of the ways you can test the effect of missing data is erasing some of your data, so creating even more missing data. And why? Because you can test whether your results are robust. That's a term used by statisticians. So let's say my network looks a bit like the thing on the left, and this might be an archaeological network, not in this case, but let's say it's an archaeological network. And if I only take the sources, the information based on one excavation, so one set of sources, it will look like this. And if I take only another excavation, it will look like that. It doesn't look very robust, right? If I look at its excavation in turn and they give a super different view of my data and nothing looks like the aggregate, it's very likely that if I found a new source, if I excavated a new site, this would change a little more the whole. So if by erasing parts of your data in different ways, you find that the general picture is not robust, probably your story is super sensitive to missing data, and you should be super cautious to say what I'm mapping is the extent of our knowledge, not the past, and so on and so forth. But in some cases, when you erase part of your data, you find the general structure is super robust, and in this case, you might think that, conversely, adding a new source that we might discover might not change the general result. So that's one way to do it, by erasing. And conversely, one way to do it that's more like simulation would be, imagine what would happen to your network if a new source were discovered. Or if we discovered, in the case of the anonymous nuns, that one of them had a name. So you could add imaginary nodes to your networks, of course, keeping a different color or whatever, and to see here too, does it change everything? In which case my network is super sensitive to missing data, or does it not change much? In which case my network has a very clear structure and is probably not super important, but nothing is ever complete. Because here I took examples in medieval history, but of course also in modern history nothing is ever complete, and even in sociology or whatever, we all have missing data, so it should not be seen as a problem, but we can experiment with different views. And of course, you cannot necessarily, as we were saying, publish all the different views in your paper, but you can say, at least I experimented with looking at this from this point of view, that point of view, those were all the same, so you can trust my general graph. But I'm aware it's not a definite answer, and I think it's something we need a collective conversation that can be fun because it's super interdisciplinary. And I learned a lot from archaeologists, for example, in this respect, but there are probably similar conversations going on in other disciplines as we speak.
Yeah, we have some more time. Yes, there are 2 more hands.
So, first of all, thank you for your lecture. And my question is, what graph metrics are most useful for your research? For example, like graph centrality, density, average degree, page rank, and what can they tell us? So this is my question.
I'm not sure I heard correctly at the beginning. You were asking which ones of these measurements or indicators were most useful?
Graph metrics, so mathematically we can describe a graph like using average degree, average weighted degree, eigenvector centrality, and these things, how can we use them in history studies?
Yes, thank you. You will tell me if I answered correctly also afterward, but to try to answer also visually. I'm super visual in spite of all my my complicated relationship with visualization. So one of the things you do classically, I think you learn to do with Gephi maybe, is you visualize, and Gephi uses the underlying matrix calculation to tell you, for example, that MR, the big blue dot here, has a large betweenness centrality. So that's a brand of centrality that tells us basically that she is bridging between 2 groups that have few other ties aside from the ties going through her. And when Gephi gives you statistics of any type of centrality, it performs matrix calculation, it performs the mathematical stuff without showing it to you. But then you just end up with a list of numbers, actually, with the betweenness centrality, degree centrality, eigenvector centrality, etc., potentially for all the individuals here. And what you end up with quite often in history is like a top 50 list, a hit parade, like a competition or podium of the highest centrality given in the text, like a table with the 3 highest centrality are these, which can be useful, giving the names. But actually, what we do more often, I think, at least in the sociology-inspired tradition of social network analysis, is take these numbers. So the most simple one is just a number of ties. The degree centrality, for example, this node here has 2 ties, so they would have a degree centrality of 2. And then you have more complicated one based on matrix calculations. So you take all this and you consider it as a new variable, a new piece of metadata on your individual. So you knew that Emma was female, you knew that she was a queen, you knew that she was born that year, and now you can also give her attached numbers to her different centralities and whatever. And then you can use those in any other type of calculation. And that was actually the part I skipped, this all goes nicely, about regression and so on in the first part of the presentation, so we are getting there. So for example, this is a case of a factor analysis done by colleagues on the history of philanthropy in Geneva. And you see, or maybe you don't see because it's small, a constellation of variables or metadata on individuals. So you have gender, you have age, you have address, you have occupation. And there you have betweenness. And so what they were thinking about was the correlation between other information we have on these individuals and their betweenness in a network of being involved in several philanthropic associations. And similarly, in a regression, I put a case a bit like that here. In a regression, discussing here the fact of migrating or not migrating when you are persecuted. You can put as one variable that's supposed to explain migration. Here it's who you live with. So it's a variant of your personal network. Do you live with parents? Do you live with persons over parents? But this could be thought of as an indicator created by network analysis. So I don't know if it answers your question, but basically, the mathematical calculations behind are actually matrix-based, but we don't have to perform those. We have software or Python function for that. And B, the output is numbers, and then you can use them in tables, in regressions, in factor analysis, or whatever you like.
Okay, but do you actually include these numerical statistics in your papers? Like, for example, betweenness, and this was this number, actually. Like visualization? Okay.
The degree centrality, for example, is quite intuitive because it's basically your number of ties. So I would write Emma had a degree centrality of 10, meaning she had 10 ties. The betweenness centrality is difficult to interpret directly. It's a number that has no intrinsic meaning or no intuitive intrinsic meaning. And so what people generally do is to say the top 3 betweenness centrality persons are those. So those with the highest betweenness are, without giving the actual number. Or the other thing we do is we export the number in a spreadsheet editor, if you like, and we use the numbers in other calculations. For example, we could say, and that's the case for Geneva philanthropists, women on average had higher betweenness centrality than men. So in this case, you don't give the actual numbers in the paper, but you give the result of the calculation, and depending on the journal, you might put the actual number, the actual average betweenness of women versus men in a table somewhere. Or some journals don't like numbers, don't like tables, and in which case you would only write women had higher average betweenness centrality than men, and not include the table.
Thank you for your answer.
You're welcome.
And we had one more question, one more last question.
Thank you very much. Could you please comment or tell more about the weird examples that you have or the exceptions and how you have been visualizing them? Do you have some examples that you could show?
But the exceptions?
Yes, well, like total exceptions, weird things, and how you visualize them in overall normal data.
Yeah.
Thank you.
Thank you. You don't always visualize them, I guess, because they often obscure the rest of the visualization or are not visible, but that's a great question. The paper on the correspondence of nonce and the anonymous nodes, those are weird nodes, is a case in point, because if you consider all anonymous as the same person, it becomes super central in the graph and it obscures all the rest. But I think she drew the graph with, she used several versions, but she drew the graph with the weird node, the exception node, anonymous as one person, to point out that this was a weird and important feature of the data, to have this non-individual in the data, and we should not forget it. So one way, if you want it not to be forgotten, is to think actually of the visualization where it is most salient. And I put a little footnote on this, on the matrix visualization, because my example is not the best one on this, but getting back to it. Not necessarily the best possible example, but this matrix visualization, if you don't have more than, say, 100 nodes, it allows you to see general patterns, like it's more dense here, but it also allows you to spot some exceptions, like this column here is a bit full, whereas everything else is a bit empty, and there's something happening here. So I personally very much like this type of visualizations where you keep a view of the whole and the parts at the same time. Let me try to find another one without spending so much time. Not being super efficient, but still trying. That's one nice thing about sequence analysis visualizations also, but here we are a bit small, but maybe you can see that you have like some static here. You have each row with a pattern. So they have been sorted in groups, so you see that this group is mostly dark gray, this group is one half colored, one half light gray, and so on. But if you look at the rows and not the columns, you can maybe see that each row is made up of individual data. And this is also a representation that allows you to keep an eye on the whole, but also keep an eye on each individual. And if we zoomed in around here, we would see exceptions. We would see, for example, the color yellow that is almost absent in the rest, and is quite present probably in 2, 3, or 5 trajectories here. So that's one of the interesting things that have been enabled actually by better computer power, is to have visual representations that keep the whole and let you look at exceptions also. But it's not true of all representations, and for example, hurdle type networks will hide exceptions quite often. But the general message is we are looking for ways to actually put more emphasis on exceptions, and for now I think we've been doing it mostly in the text, actually. We found the exceptions thanks to quantitative analysis, and then we put emphasis on the exceptions by way of the narrative. But you are also welcome to exchange stuff that I don't know as to how to better do it. And hopefully I'll find out at some point, but it's my bad because I'm not on site and I will not learn all your references.
Yeah. Thank you, Claire, again for the lecture and also for your generous offer to do the follow-up workshop. We will figure out how to coordinate it, maybe in a post-summer school survey or something. Yeah, that we will update everybody. So thank you again. One more applause. And yeah, thank you. Have a good day.
You too.
Yeah, bye.
So let's make a break so you can stand up, walk around. We also have some, what's called, not cakes, but cake similar stuff. And let's meet after 10 minutes, so a really short break, and let's have our reflection sessions there. And then we have, Yanis, we have an extraordinary walk tour afterwards.